Have you ever watched movies where characters travel back and forth in time? Before Einstein, such ideas existed solely in the realm of fiction. However, Einstein's theory of relativity brought this concept into mainstream science. Today, many scientists believe that under certain conditions, time travel might actually be possible. Today, we'll explore the roots of time travel, how this once-fictional idea became a scientific possibility, and examine whether Einstein might have erred in his groundbreaking theories. You've likely heard of Einstein's famous equation, E equals mc squared, widely regarded as one of the most iconic formulas of all time. But do you know what it really stands for? E represents energy. M stands for mass. C squared? That's the speed of light squared, a staggering number 3 times 10 to the power of 8 multiplied by itself. Here's the surprising part. Einstein introduced c squared, simply as a way to express a massive quantity. His primary point was that a tiny amount of mass can release a tremendous amount of energy, essentially describing nuclear energy. The point being, Einstein overcomplicated science for his next generations. But Einstein's influence didn't stop there. His theory of general relativity proposed that massive objects in space, like the sun, bend light and distort spacetime. According to Einstein, when light passes near a massive object, its path bends. While one might assume this bending occurs because gravity pulls the light toward the object, Einstein argued that the speed of light remains constant, so the only explanation was that time itself must slow down. But how can time slow down? This idea laid the foundation for the concept of time travel. For example, if someone were to approach a massive object like a black hole, time would slow down for them relative to someone on Earth. A day spent near the black hole might equate to thousands of years on Earth. Upon returning, that person would find themselves far in the future. Similarly, Einstein's theories also implied the possibility of traveling back in time. But doesn't this all sound a bit far-fetched? Shouldn't a theory that leads to such extraordinary conclusions be more critically examined by the scientific community? Humans have tracked time for millennia. But what exactly is time? Is it a physical dimension, a tangible attribute of the universe, or merely a conceptual tool we use to communicate? Time has undeniably shaped human progress. However, the question remains, does time have an intrinsic existence, or is it simply a human invention for organizing our lives? Scientists often cite experiments supporting Einstein's theories, such as the observation that clocks on satellites run faster than those on Earth. They claim this proves that time slows down in stronger gravitational fields. But is this truly evidence of time's distortion? Or are we misinterpreting the data? Is gravity influencing time, or is it influencing the clocks? Let's consider a thought experiment to challenge Einstein's ideas about time and space. Imagine sending a person named Bob into space wearing a watch. According to Einstein, time would move faster for Bob in space. But are the forces of the universe acting on Bob's identity, his name, or his physical body? The universe doesn't recognize human names like Bob. For the universe, Bob is just another mass. Similarly, the forces of the universe act on Bob's watch, not the concept of time it measures. The forces of the universe act on Bob's watch, which in turn, acts on the time that it's supposed to be keeping. The forces of the universe don't know the concept of time, they only know matter. To illustrate, think of placing 2 carrots, one in a fridge and the other outside. The carrot in the fridge takes longer to rot, but does that mean time has slowed down for it? Of course not. The different rates of decay result from environmental factors, not a fundamental alteration of time. If Einstein was mistaken about time, why haven't other scientists disproved him? The answer lies in the nature of scientific progress. Just as religion has its disruptors, prophets who challenge and redefine beliefs, science too relies on revolutionary thinkers to break existing paradigms. Before Einstein, Newton was the scientific prophet whose laws dominated for centuries. Einstein disrupted Newtonian physics and became the new standard. Since then, no comparable mind has emerged to challenge Einstein's theories. But eventually, someone will. A new disruptor will come along to disentangle time from spacetime and reshape our understanding of the universe. Until then, we have to live with the concept of time travel into the future or the past.